All right, you have to review for a final. You have today and the big review day that's coming on in your class. Is that Friday? Thursday? Okay. Tomorrow. Okay, so today and then tomorrow, and then we have to have covered everything for an entire semester, which is 4.5 months. Can that really happen? Can I cover everything in that much time? No, no way. But we have got practice problems for you on everything. That means there's a ridiculous number of practice problems also, which means that I can't in good conscience assign all of them to you and say do them all, because there's no way. Like, you'd be doing math only for the next 5 days. So I'm going to assign you a subset of those problems that you should do for practice, and right now I want to focus in on 4 of the areas. What areas, you ask? These areas. These are all the things. If you find this folder, it has a gigantic collection of review for you. It's called, surprisingly enough, Review. Semester 2 Final. Okay, so basically it's review for that final, and there's a whole bunch of folders. We're going to go through them in order, and I'm going to teach you the first 4 today. And our longer session tomorrow, the 2-hour deal, I'll be able to teach you a lot more. I'm not going to try to teach you everything, these 4 even. I'm just going to hit the high points. The first one's applied quadratics, and I'm going to tell you after the video which ones I want you to actually do in applied quadratics. We're not doing all the problems again in all the sections. There's just too many. So it's awesome that they're there, though. So if you know I'm good on every section except I'm terrible on complex numbers, well, then you can spend all your time on complex numbers, do all of those problems if you want to. Then do some of the other ones, because I'm going to assign some of the other ones. But you can focus where you need to focus. All right, so applied quadratics. Let's see if you remember anything about this. This would be typically a question where they say they have launched something in the air, and the graph looks like this, and the equation looks like this. Everybody type this one into your calculator. Y equals negative 4.9x squared plus 5x plus 7. And they would typically ask you 3 things about that. They'd ask you for what was where was the ball at time 1 second, for instance. Okay? So my first question for you is, where is the ball at x equals 1? You got to know how to do second calculate something to do that. Gentlemen, you're still talking. Stop that. Number 2 is not just where is the ball. When does the ball hit the ground? That's another math function. And the third question about it was, what was the highest that it ever went? Its max height. And when did it happen? Basically, that's this spot. One other little side note that should be super easy. How high was it when they started this problem? 7. It's just the y-intercept, which is where x equals 0, so that cancels, and the answer is that. That's how high it was when it started. That's super easy. But the other 3 things they'd ask you would be those 3. Would you please type that into your calculator and see if you can answer those 3 questions for me? I'll pause for a second while you try that, and then I'll show you how. I'm not going to give you tons of time, because I am going to show you how in a minute, and that will take time too. So I'm going to pause. I'm back recording again. Here is the graph, and what does it tell me? Well, first of all, where's the ball at x equals 1? Second. Everybody do this, please, with your calculator to make sure you knew how to do it right. Second, calculate which one? Value. And then you say x equals blinky, and you say what? X equals 1, and you hit enter, and you get 7.1. Raise your hand if you had that one right. What does it mean? 7.1 chickens in Venezuela? No, what does it mean? 7.1 meters off the ground. How did you know it was meters? Because it was 4.9 at the beginning, which means the gravitational constant was done in meters. Very good. All right. If it was like 16 point something, that would be feet. But we usually do it in meters, so don't worry about that. All right. Next one is, when did the ball hit the ground? That is called second calculate the 0. The 0 means where it touches right down here. So I'm going to get really close to the 0. I got to get to the left of it. There, I'm to the left of it. I know I'm above it, but I'm also to the left of it. And then I go to the right of it. And then to go on top of it, I just kind of get close as I can get. And there it jumped to it, 1.0 or 1.8. And the answer says y equals 0. What does that mean? What about y is what again? What's y again? Height. So it's height 0 is at 1.8 what? Seconds. 1.8 seconds. So that means about 2 seconds after the ball was launched, it's hit the ground again. All right. And what was the highest it ever went? Well, that's the max thing. So we go to second, calculate maximum, and that's right there. And I get to the left of the maximum. Doesn't matter if I'm perfect, I just need to be somewhere to the left of it. Then I get to the right of it, and then I just hit enter for the last one. It'll jump right to the top, and it says 0.51 and 8.3 I would round it to. So that's 0.51 means seconds. Half a second into its flight, it reached its maximum of 8.27 feet. Now this thing really wasn't very lively, was it? It started at 8 feet. And it maxed out at, sorry, it started at 7 feet and it maxed out at 8.3 feet. Okay, so this is like a toddler going with the ball, okay? Which part of this, okay, fine, is standing on a chair. Okay, fine, standing on a ladder. Anyway, which number could I have changed to make this thing go a lot higher? The 5. And that one's called the what? The velocity. What's that one called? Starting height or initial height. Okay, good. Can I change that? Well, not unless you leave where? Earth. And you move to like Pluto. We did talk about gravity. And the gravity on Jupiter is 2.5 times our planet's gravity. So if the Jupiterians ever decide to arrive, be very afraid. Because for them, this place would be like Candyland. They'd be like jumping over buildings and stuff because the gravity is so incredibly different. Now think about it. What if we had to invade Jupiter? Would you have fun walking around on Jupiter? No. First of all, we couldn't breathe. Second of all, the 2.5 times the gravity means that you got to basically carry you and half of you around to be able to just walk around. It would be that heavy to just like move. So we probably wouldn't want to invade Jupiter. All right, and the sun, which is completely ridiculous, I think it's like 112 times our gravity. Now, although I've heard it's very hot there, so we probably wouldn't want to go there anyway. Okay, let's move on to a different kind of problem. This is about not applied quadratics anymore. I think you guys seem to be good on that. This is about complex numbers. And do you remember completing the square? It's been a while. I'm going to do one really fast for you. Let's say I had this, and I wanted to know what its vertex was. That's what complete the square is good for, is when it's done, it'll look like this. I need a squared, sorry. It'll look like this, x plus 3 squared minus 11 or whatever. And then I know the vertex is this and this, negative 3 comma negative 11. Why is it opposite of that? Things are always counterintuitive in there, so it kind of makes some sense. Negative 3 comma negative 11 is not the right answer, though. Let me show you how I'd actually get the real answer. First thing I say is that negative 7, I don't want a negative 7 there. I'm going to move it over and instead put something else there. I'm going to put a number that would be perfect. And the little German boy tells me what to put there. Remember? Half and square. Half of 6 is 3. 3 squared is 9. So there we go. Thank you, Deutschland. Y equals x plus 3 quantity squared. And that goes together and makes minus 16. So what's the vertex really? Negative 3 comma negative 16. Do you remember doing that? I'd like you to try one. You try telling me what the vertex is for this guy then. Y equals x squared minus 8x plus 2. Try to find the vertex for that by completing the square. On this kind of problem, we would probably throw in a variable so that you wouldn't be able to do it on the calculator. I'm going to pause for a moment. All right, so here's how you would have done this one. That 2 moves over, plus 2 over there. I put, instead of this 8, I use half of it and square it, which would be 16. If I add 16, I got to subtract 16. That way, this whole equation stays balanced. It is an equation, see? All right, so now I'm going to take this part and this part and turn it into x, and I got to go minus 4 squared. Why minus? Because this has to be a negative in the middle here. X minus 4 squared, and then these together make negative 14. Raise your hand if you had that right. Good. Now, what is the vertex? 4, negative 14. Very good. You noticed that it's not the exact number. It's the opposite of that number. Okay. So then if I told you that, and then I said, well, if you only knew that and you knew the y-intercept, would you kind of know what the graph looks like? If you know that the vertex is here and the y-intercept, do you kind of know what the graph looks like? Well, you should. It's a parabola. And if I know that it's at 4, negative 14, that means it's like there. And then if I know the y-intercept is actually at, do you remember from the original problem? It had a 2 there, right? So the y-intercept would be 2. So that would be like right here. Can you picture in your mind what this thing looks like? If you know the vertex, you know a lot. You know it makes its turn right there. So it must look like that. That make sense? All right. That is something out of complex numbers. Here's another thing out of complex numbers. You have to, and this is on the ACT test sometimes too. And I can't say it's for sure going to be on the one you take because there's 150 or 200 skills they can pick from. But this is one of the things they often throw on there. Multiply that puppy out. And when you have an I squared in your answer, try to remember what to do. I'm going to pause while you try that one. The first make 8. The outside makes negative 2i. The inside makes positive 12i. And the last makes negative 3i squared. And these two can go together before I do anything else. 8 plus 10i. And then this right there makes what? Negative 1. I'm glad many of you remembered it. Negative 3 times negative 1 makes positive 3. And then I put it all together. And I go like this. 10i plus 11, true or false? False. Why? Because the 11 has to go first and the I has to go last. I'm proud of you for knowing that. Some of the classes I don't think know that. All right. The imaginary numbers are supposed to go last. Doesn't matter that much. I've been told that it isn't. They often wouldn't even mark that wrong in pre-calc next year, but it's still something you should know. Why not know the right way to do it? Imaginary is at the end. All right. Next topic. Factoring. No, wait. I squared. You know I squared was negative 1, right? What's I to the 5th? Don't say it. Figure it out. Write it on your iPad. Turn it my way. I'll tell you if you're right or not. Remember, I squared is really like I to the 5th is really like a bunch of i's, right? See if you can figure it out. I to the 5th. I'm waiting until I get a few more answers before I start verifying an answer. Yep. Is that a 1 or an I? That's an I? Good. Okay. Yes, you guys figured it out. It's I. Isn't that kind of weird? 1 to the 5th equals 1. That one makes sense to me. But I to the 5th, it actually changes back into itself after doing a whole bunch of things because it isn't I in between. You know what I mean? When you go to I squared, it turns into negative 1. When you go to I to the 3rd, it turns into negative 1i or negative I. When you go to I to the 4th, what are you at? That's a couple I squareds, right? Yeah, that's crossing my I's. That's weird. And that's negative 1 times negative 1, and that's positive 1. All right. Now, let's go to x squared plus 3x. This is factoring. See if you can factor this puppy. I'm wrong. X to the 3rd plus 3x squared minus 3x minus 9. That, if you do it right, will factor. And I want you to try factoring it with any method you like, and then I'm going to show you the other way you could have done it. You can use a calculator for this if you want to. Remember, I didn't ask you for the graph, but I asked you to factor it. Here's how I probably would have done it. You remember the divide and conquer method? You divide it into two parts. Some people call it factor by grouping, but it's much more dramatic to divide and conquer. It was a very effective strategy in war. All right, so I'm going to divide it and conquer it. I'm going to take the green part, factor it. X squared comes out, x plus 3 is left. And then I'm going to factor this part. Negative 3 comes out, x plus 3 is left. That's the same. Yay, they come out to the front. X plus 3. And then what's left here is x squared minus 3. And I have factored it. Okay, I'm back. And now I'm going to show you the other way you could have done it. Because not all of them factor by grouping, but this way I'm about to show you works on almost all your problems. Do you remember how it had a negative? Was it a negative 3 as one of the solutions on that last one? Here, let me just undo the erasing I just did. Yeah, negative 3 would have been one of the solutions. You get that? If I had graphed it, here's what it would have done. It would have made it go like this. It touches at negative 3. Now, I don't know what the rest of the graph does, but I know it probably does something like that or whatever, but I know it touches at negative 3. That tells you how to go like this. You remember this way? Where that's a 1, 1, 3, negative 9. Everybody right now do the synthetic on that. I want you to practice synthetic. Remember, Snoop Dogg tells you how to start. Very good. So that drops down in case that was too cryptic. I apologize in case Snoop Dogg is listening. It's actually Snoop Lion now. Did you change it back? Yeah, I think he probably just wanted a little attention. It's a good way to change your name, get a little attention. Prince did that for a while. Did you know that? Changed himself to a symbol. Yep, he didn't have a name anymore. He officially, legally changed his name to a symbol. I don't know what the symbol was, but it was this weird symbol. Then he required that everybody not call him Prince. He said, and since they couldn't pronounce the symbol, they had to call him the artist formerly known as Prince. Okay, anyway, that's what you can do when you're incredibly rich and wear purple pants all the time. All right, here we go. 3 times negative 1, negative 3, add them, 0, multiply them, 0, add them, negative 3, multiply them, ooh, positive 9, it worked, yay. Do you remember how this works? You need to know this for the final. So then this comes down and becomes x plus 3. Remember how that's the root and that's the factor? You get how those go together? They're the opposites, kind of. Then this one, do you remember how these are the x's and these are the x squareds? I need a little plus between those two. Please don't talk during this time. Then, final answer was x plus 3 and x squared minus 3. That way works to factor even really big things that you can't factor by grouping. All right? I don't want it to take too much time, but if I gave you one like this, x to the 5th plus 3x to the 4th plus 5x minus 17, you could graph it. If it touched, you could go, oh, it's touching at 3. I don't know exactly how the graph would look. I know it's odd, so they would have to be going opposite directions. Remember that? Anyway, I'll talk about that later. So if it touched at 3, you could go, okay, 3's my root, and then I do synthetic on this. 1, 3, 5. Ooh, I get missing terms too. And there's a couple missing terms in there, so I have to say 1, 3, 0, 0, 5, 0, 0, 5, and negative 17. Anyway, that's a way to do a quick reminder of factoring using a calculator. Yes? You will. I don't think you'll be doing long division on this test, but I am not positive. I'm not going to review it for you right now. I know that you could always do synthetic, and since it's a multiple choice test, I'm like 95% sure it's all multiple choice. Then that means we can't really make you do long division, right? We could make you do long division, then you'd say, well, I'm going to do synthetic, and you get the answer that way. All right, let's move on. There's the next major topic to cover. Making sure that you know how these higher degree polynomials work. Do you remember these deals where there was bounces like that -2 here and let's say a cut through at 7? Do you remember how to say, oh, I know it's an odd function? How do I know that's an odd function? Yes, sir. Opposite. They're going opposite directions. What's going opposite directions? Ends. Okay, so this end's going up, this end's going down. Since they're going opposite directions, this must be odd. Now, could it be an odd number like x to the 1? That's an odd number. Just x. Could it be that? No. Here's why. The degree has a bounce and a cut through. Remember what bounces are worth? 2 cut throughs are worth? It makes a total of 3. So we think it's a degree 3, but do you remember we always had to say degree 3 or more? Why? Because there could be imaginary roots that we don't know about. Okay, so this is degree 3, probably, or it could be more, because there might be imaginary roots. Can you see imaginary roots on the graph? No. So here's why we have to do that, because what if the graph goes like this? Do you think it doesn't ever touch? See, there's no roots. Does that mean that there are no roots at all? No, it's got roots, they're just imaginary roots. So you can't always tell how many degrees a graph is by looking, or a equation is by looking at its graph, because sometimes they're like this and that one has a bunch of imaginary roots. How about this? Do you know if it's even or odd? It's even, so it's probably degree 4 or more. You always have to say or more at the end of your answer. I don't know if they're going to try to burn you on that on the test or not, but I wanted to remind you about that. So let's say I asked you to write the equation for this one, -2 and 7. Would you please give it your best shot to write the equation for that? It starts with y equals. Remember how to do this? If you don't, I'll teach you in a second. I'll give you a hint. You need 2 sets of parentheses. You need a parenthesis for this one and a parenthesis for that one. Y equals 2 sets of parentheses. And does anybody feel confident that they remember this? Well, come on, you big chickens. Got one person who's confident. Tell me what you think it is. X squared plus 2, okay, and then what? X minus 7. You are very close. Can anybody improve that in some way? You put the squared on the outside, yes. Seems like a small point, but it does matter. All right, thank you for being willing to share. Now, there is one more thing that almost everybody gets them wrong because they say it's that, but there's one more little thing. Nobody's even been able to figure it out. Oh, one person. It has to be negative. Yes, because it's going down in the end. Do you remember that? On the right-hand side, if it's going down, there has to be a negative in front. So, easy to forget that. Nice catch. One person was able to pull that out. Okay. So that is an equation for this graph. All right, now, I have to say we haven't factored in a stretch factor, okay, because we don't know how steep this is, and we just know it touched at -2 and it touched at 7. Because like, if I graph this and I show it touching at -2 and touching at 7, do you get that, how that graph looks totally different than the other one? And yet it would have the same equation. So we haven't factored in a stretch factor, so I'm just warning you that in calc you'd have to definitely be more careful than that. You put an A here, which means as a stretch factor we don't know, called A, and then you could figure out what the stretch factor is. But we're not getting that deep in these. All right. It has to be negative, though, in front of that. Or you could just put an A here where A is negative. You could do that, too. But anyway, just acknowledging that we don't know how stretched this thing is. All right. Your next one is about, okay, is coefficient. I think I may have covered it all. Right, equation, and then, oh, there's one more kind of root I wanted to talk about. That kind. That's not a bounce, and it's not really a cut through. What is it? A triple root. If you actually graph that, that's x to the what? That's x to the third. That's x cubed. And so that's a degree 3, obviously, if it's x to the third. And it's going up on one end, down on the other. Does that make sense for an odd function like that? Yeah, they should be going opposite directions like that. Okay. Then I think I've covered everything I want to for today, and I'll tell you guys which parts of the packet and stuff I want you to do.